Okay, good afternoon and welcome to lecture number 21. And in this lecture, we will be studying the Mason's gain formula. In the last lecture, we talked about some fundamental about signal flow graph. And then in this lecture, we'll study Mason's gain formula, all the details of Mason's gain formula, and then how to apply this Mason's gain formula to find out the overall transfer function by using SFG. We'll take one problem on that one. So just look at this one. Yesterday we talked about this one. Consider the signal flow graph given below and identify different forward paths and then feedback loop, self loop, and so on, or two non-touching loop, three non-touching loop, and so on, because all those terms are there in the Mason's gain formula. Okay, so you know that forward path means signal will travel from input side to output side. So how many ways are there or how many paths are there that we have to identify. So first one is that, like for example, for a given problem here, the forward path gain will be Z1 into G2 into Z3 into Z4 into Z5 into Z7, right? So this is one forward path. And another forward path is from Z1 to Z2, Z2 to Z3, Z3 to Z4, and then it may go like Z6 and Z7. So this is your second forward path. Okay, means see that forward path signal direction is from input side to output side, right? So this is unidirectional forward path, right? So I hope that you have understood, okay, how to identify the various forward paths from the given problem. Then, okay, identify the loops. How many loops are there in the given problem? So you know that this is one loop. So what is the loop gain of this one? So that is equal to just product of this loop gain. So G2 of S and H1 of S. See that signal starts from this node and terminate at that node. So that is called the loop. So the gain product of loop will be G2 of S into H1 of S. Just you are taking the product of these two paths gain. So this is the path gain of this path, that is G2 of S, and this is the path gain of this path, so that is H1 of S. So product of this one will be G2 of S into H1 of S. So this is one loop. Another loop is that Z4 of S into H2 of S. See that. Yesterday we talked about this. This is not a loop because the signal direction, okay, this is also from basically it's not like signal is starting from the same terminal and terminating at the same terminal. It's not like that. It is starting from the same terminal, both signals here, but they are terminating at the other terminal. So this is not a single loop. So this is forward path basically, or they are connected in parallel. So Z5 and Z6 are connected in parallel. So this cannot be considered as a loop. So second loop is this one. What about third loop? Third loop will be like Z4 of S into Z5 of S, and then again signal will come back to this location via H3 of S. So second loop will be this one, Z4 of S, Z5 of S, and H3 of S. Is there any fourth loop? Can you identify there is any fourth loop? Somebody? I have told you three loops. So this is one loop, this is another loop, and a third loop is this one. Okay. Is there any fourth loop in the given problem?
Sir, G4, G6, H3.
Very good. So this is Z4, Z6, and H3. So this is the fourth loop. So loop gains like this is first loop, Z2 of S into H1 of S. Then second loop is this one, Z4 of S into H2 of S. Third loop is this one, Z4 of S, G5 of S, and H3 of S. And then fourth loop is like this, Z4 of S, Z6 of H, and H3 of S. So you have to identify all those loops individually, right? If you miss any one, then your overall transfer function will be wrong. So you have to be very careful while identifying the loops from the given signal flow graph and so on. So now, right now, we have seen how many forward paths are there, how many loops are there. And now, after that, we have to see how many loops are not touching to each other. See that. This first loop and second loop, are they touching to each other? Means whether they have any common node? No. So this combination Z2 of S, I'll call this as a L1 and this as a L2, this as a L3 and this as a L4. So L1 and L2 are not touching to each other. L1 and L3 is also not touching to each other. L1 and L4 is also not touching to each other. So you can have three combination of two non-touching loops. But what about this L2 and L3? Yes, they are touching to each other. L3 and L2 and L4 are also touching to each other. L3 and L4 are also touching to each other. So we will not consider the loops which are touching to each other, right? So see that this one non-touching loop one is basically this combination and then this combination. Second one is this combination and then L3, and third one is this combination and this fourth loop. So you got two non-touching loops gain product, right? What about any three non-touching loop gains? No, there are no loops available, three loops available which are not touching to each other. So maximum three combinations are available in this given problem, right? Now consider this problem and identify the following, right? So like for example, which is input node here in the given problem? Where the signal starts. So X1 is your input node, okay? Which is the output node? Where signal terminates. So X8 is your output node, okay? What about the forward path? So this path 1 into A32 into A43 into A54 into A65 into A76 and into 1. So that will be the first forward path, right? Can somebody tell me other forward path? Yes. Right. So you are saying this path, right?
Yes, sir.
Exactly. Right. So this is second forward path. Can you tell me any third forward path available?
No, sir.
Don't you think that X1 and then this, okay, this one 1 and then this A72 and then 1, this is also forward path, right? So this is a third forward path, right? So you can identify, see, that's why actually you have to be very careful while identifying the forward paths and loops and so on. If you miss any one, then your overall transfer function may be wrong, right? So we have identified there are three forward paths. Then what are the feedback paths or feedback loop? See that this is one feedback loop, okay? Then this is second feedback loop. Then this is third feedback loop, fourth feedback loop, fifth feedback loop, okay? And then this one, okay, is sixth feedback loop, okay? What about this one? This one A42, and then this one, and then again this one will be also a feedback loop. Also, this is a self-feedback loop and so on. So we can find, okay, all those feedback loops, then which, okay, determine the loop gains of feedback loops that we will find, and also determine the path gains of forward path. So let us look the input. I have just solved this problem. So input node is X1 and output node is X2, X8. Then forward paths are like X1 to this is one forward path. Okay, this is another forward path. Then this is third forward path. So we have three forward paths identified. Then feedback loops. So already we have seen that this is one feedback loop. Then this is second feedback loop. Then this is third feedback loop. Then this one will be fourth feedback loop, fifth feedback loop. Okay, then this will be self feedback, that is a seventh feedback loop. Then after that, this will be the complete feedback loop, that is eighth feedback loop. Then after that, this will be, see that this one X5 to X6, X6 to X7, and then this one. So see that this is the signal direction. So this is also a feedback loop. And yeah, one more is left. That is this signal starts here, and then again it will come back, and then like that way, and it will terminate at this loop, at this node. So this is also a feedback loop. So you have to be very careful while finding the feedback loops. Okay, then this is also another feedback loop. Okay, so like this. Okay, this signal. So it starts from here, comes here, again here, and then so like that way it will come back and terminate at the same node. So this is also another feedback loop. Okay, self loop is this one. It starts from x7 and terminate at x7. Okay, so you have how many loops are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 in total. In total, 10 loops are there. So you have to identify it very, very carefully. Okay, then what are the forward path gains? So this is one forward path gain. So just you have to take the product of this one into A32 into A43 into A54 into A65, E76, and so on. And then second one is 1 into A72. This is, and then third one is 1 into A42, A54, and so on. So like that way, these are the forward paths gain. Now, so all those terms like for forward path, then feedback loop, then 2 non-touching loop, 3 non-touching loops, all those terms are there in this Mason's-Gain formula, by which we can find out the overall transfer function by using single flow graph. So this Mason's rule was published in 1953 by S.J. Mason. And this method, with this method you don't have to reduce any block diagram and so on. Just from this one, you have to identify which are the forward paths, which are the feedback paths, which are the 2 non-touching loops, which are the 3 non-touching loops, and then just you have to put those values in the formula. You'll get directly the this one overall transfer function of that system. Okay, so the block diagram reduction technique requires successive application of fundamental relationship in order to arrive at the system transfer function. So you have to reduce that block, simplify that block by using rules, and then you have to simplify till you get the final transfer function. But here, with the Mason's rule or this one, signal flow graph, you don't try to go for reduction and so on. So Mason's rules for reducing the signal flow graph to a single transfer function requires the application of only one formula. So you have to find out all the terms in the formula. So the formula was derived by S.J. Mason when he related the signal flow graph to the simultaneous equation that can be written from the graph, right? Now, so this is the overall formula of Mason's-Gain formula to find out the transfer function. So you know that transfer function is the Laplace transform output variable. Output variable is C of S, and to the Laplace transform input variable. So input variable is R of S. So C of S and R of S can be directly given by summation. Okay, in the numerator, summation over 1 to n pi delta I. Okay, divided by delta. Now, let us look at what is meant by n, what is meant by I, what is meant by pi, what is meant by delta I, and what is meant by delta. So we'll see individual terms, and then after that, by using the this formula, we can find out easily the transfer function of given system. So n means basically how many number of forward paths are there. See, in earlier problem, just whatever we have studied, there were 3 forward paths. So the value of n will be equal to 3. So n is decided by how many number of forward paths are there in a given problem. So n is nothing but the number of forward paths. So this will be, suppose for example, if it is 3, so it will be from I is equal to 1 to 3. If there are only 2 paths, then it will be I equal to 1 to 2. If it is 1, then it will be I equal to 1 to 1. Right. And then this one will be the pi. Suppose, for example, what will be this one? If forward paths are 3, then summation over I equal to 1 to n, that is 3. Then this will be pi delta I. So what will be this equation? If you simplify it well, it will be P1 into delta 1 plus P2 into delta 2 plus P3 into delta 3. Just if you expand that one with n is equal to 3, so this will be P1 when I equal to 1, and then this will be delta 1. So P1 into delta 1 plus, this is summation, so plus P2 into delta 2 plus P3 into delta 3, since the value of n is equal to 3, right? Now, what is this pi? Pi is basically when you are considering I equal to 1, so that will be the first forward path. When you are considering I equal to 2, that will be your second forward path. So pi is the ith forward path. So first, if I equal to 1, first forward path, I equal to 2, second forward path, and I equal to 3, third forward path, right? Then What about this delta? We'll see delta I later on, but okay, now we have studied what is by n, what is by p, okay, and pi. Now let us look at delta, and then after that we'll see delta I. So delta is the determinant of the system. Now how to find out the determinant of the system? So this delta determinant of the system is given by, see that delta is equal to 1 minus sum of all individual loop gains. Now see that in the earlier problem there were basically 10 loop gains were there. So what you have to do, just you have to take, suppose for example, if I call first loop gain as a L1, second one as a L2, so this will be in bracket 1 minus L1 plus L2 plus L3 plus up to L10, right? Then plus, see that this sign is alternate plus minus. So this is plus and then minus and then this plus and again minus and then plus and then minus it will come. So 1 minus sum of individual loop gains. So and then after that, what is this one? So this is the sum of product of the gains of all possible two loops that are not touching to each other. So we have to identify how many loops are there which are not touching to each other. So just you have to take the sum of product gains of those loop gains, right? So we have to add those things. Now in see an earlier problem we have seen that there are two non-touching loops which are not touching. So just we have to take the gain product of that those two non-touching loops, and then we have to sum that one, right? Then similarly minus sum of the product of gains of all possible three loops that do not touch each other. See that here two loops, here individual loop, here two loops which are not touching to each other, and then here three loops which are not touching to each other, and then plus here what will be that one? So four non-touching loops. Then again this will be minus 5 non-touching loops, then six non-touching loops, and so on. So like that way the value of delta will be determined. This will be more clear when we will take the problem on that one, right? So once you have calculated the value of delta, then you can calculate the value of delta I. Delta I is basically the value of delta for that part of the block diagram that does not touch the ith forward path. So you have to eliminate all those loops which are touching to that forward path, and limiting value of delta, whatever it remains, so that will be the delta I. So see that delta I is value of delta for the part of the block diagram that does not touch the ith forward path. Now, if all the loops are touching to that forward path, then value of delta will be what? So this whole thing will be 0 and only 1 will remain. So delta I will be equal to 1 if there are no non-touching loops to the ith path, right? So in that way, value of delta I will be calculated. So delta I will be associated with pi. So means if you are calculating p1, you have to calculate the delta 1. If you are calculating p2, then you have to calculate delta 2, and so on. So like that way, if 3 is there, n is equal to 3, then you have to calculate p1, p2, p3, and delta 1, delta 2, delta 3. And then you have to take the product in the numerator, and then in the denominator, it will be the value of delta. So that delta is calculated like this. I hope that you have understood how to calculate the value of n. N is nothing but how many number of forward paths are there. If there are 3 forward paths, value of n will be 3. And then pi is nothing but the ith forward path. Like for example, if n is equal to 3, then you have to find out 3 forward paths. So p1, p2, and p3 forward paths will be there. And then delta I will be the value of delta associated with, like for example, if it is p1, then there will be association with delta 1. So you have to find out the value of delta 1 where the loops are not touching to that forward path. So that value of delta you have to put as a delta 1, right? Then you have to calculate delta 2, delta 3, and so on. And then delta you have to calculate delta like this: 1 minus sum of all individual loop gains. See that this sign is alternate changing sign. So this is plus, this is minus, then plus, minus. So you can keep or remember this very well. So in the first term, it is individual loop gains, sum of all individual loop gains. In the second term, what is that? Sum of product of 2 non-touching loops. Then in the third term, it is sum of product of 3 non-touching loops. In the fourth term, it will be sum of gain product of 4 non-touching loop, and so on. So like that way, you have to remember how to calculate the value of delta, right? Now, the systematic approach for finding the overall transfer function by using signal flow graph is that first step, okay, in the first step, what you have to do, you have to calculate the forward path gains pi for each forward path I. Like for example, you have to identify how many forward paths are there. Okay, if it is n is equal to 3, then you have to find the loop gain of all those p1, p2, and p3. So first thing, what you have to do while solving the signal flow graph is that calculate the forward path gain pi for each forward path I. Once it is done, calculate all loop transfer functions. Okay, so you have to find out the all loop gains. Then after that, consider 2 non-touching loops. So you have to take the gain product of 2 non-touching loops, then 3 non-touching loops. And once you know that, okay, there are no more than 3 non-touching loop or 2 non-touching loop, then you have to stop there. Once you have the individual loop, 2 non-touching loops, 3 non-touching loops, then from that one you can calculate the value of delta. You know that delta is 1 minus summation of individual loop gains plus sum of gain product of 2 non-touching loops minus sum of gain product of 3 non-touching loops, and so on. So in that way, you have to calculate the value of delta, right? So once you calculate the value of delta, then you can calculate the value of delta I. So this delta I will be associated with pi. So you have to identify which loops are not touching to that forward path. So you have to eliminate those, and then remaining value of delta will be the delta I. So calculate delta I as portion of delta not touching forward path to I. And then once you calculate the value of delta I, delta, and pi, just you have to put those things. Just you have to put those things. Okay, just you have to put all those things in the Mason's gain formula. Okay, it's a gain, right? I think somebody's mic is on. Please mute that one.
मोठीले येतात तिले आंबट घराके चालत नाही तेलकट नाईने नाही चालत तिने खाल्ली आंबट गाडी आईने नाही खाल्ली तिचं म्हणणं
Preeti, right. Okay, so look at this one. Okay, this is first problem we are going to take. Have you understood it? Okay, let me know. Have you understood the Mason's gain formula? It will be more clear with example, right? Shall I take the example? Feedback from your side is important.
Yes, sir.
Okay. So, okay, look at this problem. Okay, thank you very much. So look at this problem. Okay. Okay, so look at this problem, and then by using Mason's gain formula, you have to find out the transfer function of this system, right? So, what is your first step? Your first step must be that you have to find out how many forward paths are there. So you have to find out the gain product of forward path. So that will be our first step. Second step is that gain product of individual loop. Then third step is gain product of sum of gain product of 2 non-touching loops. Then fourth step will be sum of gain product of 3 non-touching loops. Once you have calculated all those things, and if nothing is left, then you have to find out the value of delta. Then you have to find out the value of delta I. And once you calculate the pi, delta I, delta, just you have to put those things in the Mason's gain formula. That will give you the overall transfer function of that system. So like that way. Now look at this one. So this is basically given problem, and you have to find out the overall transfer function by using Mason's gain formula or signal flow graph. So our first step will be to find out the gain product of forward path. So this is the first forward path, 1 into Z1, Z4 into Z2, and then into 1 into 1. So first forward path will be Z1, Z2, and Z4, right? What will be the second forward path? Can you tell me in the given problem? Second forward path.
From G1, G4, G2.
Right, Z1, Z4, and Z3. So there are two forward paths. So what will the value of n there?
2, sir.
What is the value of n now?
2, 2.
2, right? So n is nothing but the number of forward paths. So n will be equal to 2. So your first P1 is the first forward path. So that is 1 into Z1 into Z4 into Z2 into 1 into 1. So that will come Z1, Z2, Z4. And the second one is 1 into Z1 into Z4 and then Z3 and into 1. So that is Z1, Z3 and Z4. So we have calculated the value of n. We have calculated the value of all forward paths. Now next step is that we have to find out the individual loop gains. So your first individual loop gain will be Z1, Z4 into H1, right? So Z1, Z4 into H1. Then what will be the second loop gain? How many loops are there? Can you calculate?
Sir, 2 loops.
Okay, tell me second loop.
Sir, minus, sir, G1, G4, G2,
Uh-huh.
minus H2.
Very good. So this is Z1, Z4, Z2 and minus H2 will be second loop. First loop is Z1, Z4, H1. Don't you think that there is one more loop?
Yes, sir.
Okay.
G1, G4, G3, minus H2.
Right. So this is third loop. So number of loops are this Z1, Z4, G3 and minus H2 is third loop. Now see that you know that to overall transfer function is equal to, see that there are two forward paths. So overall transfer function will be equal to C by R. Since in numerator it was summation over I equal to 1 to n pi delta I. So if n is equal to 2, so your formula will be P1 into delta 1 plus P2 into delta 2 divided by delta. Now there are three playback loops. So first one is this one, then second one is this one, and third one is this one. All right. So we have calculated the L1, L2, and L3 individually. Now look at these three loops. Okay, whether there is any combination of two loops which are not touching to each other. If this is first loop and this is second loop, so they are touching to each other because they have common node. Like this is common node, this is common node. Okay, what about first and third one? So first one, third one. So first one is this one and third one is this one. So for both this node and this node is common. So they are touching to each other. So there is no any combination of two non-touching loops. So okay, if there is no two non-touching loops, there will not be any question of three non-touching loops and so on. So value of delta will be equal to what? Delta will be equal to 1 minus sum of all individual loop gains. Why we have terminated here? Because there are no combination of two non-touching loops. Now, what is this? So 1 minus L1 plus L2 plus L3, because we have three loops, L1 plus L2 and L3. So value of delta will be equal to 1 minus L1 plus L2 plus L3. So we got the value of delta as 1 minus L1 plus L2 plus L3. So if you put the value of L1 here, G1, G4, H1 minus Z1, Z2, Z4, H2 of this L2, and this L3 is minus Z1, Z3, Z4, H2, right? So now we have to find out the this one, delta 1. So delta 1, path 1 is this one. Now for this path 1, okay, which loop is not touching? See, there are three loops. This is first loop, this is second loop, and then this is third loop. So all those three loops are touching to that path. So we have to eliminate that. Okay, so we have to eliminate all those loops which are touching to this one. So this loop is eliminated, this loop is eliminated, and this loop is also eliminated. So what is this one? Delta 1. Delta 1 will be 1 minus how many loops are left? There is no single loop left, so 1 minus 0, so that will be equal to 1. So delta 1 value is coming as a 1. Are you getting how we have calculated the value of delta 1? Just you have to eliminate the loops which are touching to the first forward path. Now our first forward path is this one, G1, Z4, and G2. So G1, Z2, Z4 is this forward path. And for this forward path, okay, we have to find out the value of delta 1 such that, there will be only loop which is not touching to that path. But here the first loop is touching to this one, so we have to eliminate this loop. Your second loop is also touching to this path, so we have to eliminate that one. Your third loop is also touching to this one, so we have to eliminate. So L1 is eliminated, L2 is eliminated, L3 is eliminated. So this part will be 0, so 1 minus 0 will be 0. So delta 1 value is coming 1, right? Now similarly for the second path. Now second path is Z1, Z4 and Z3. For this path also this loop and this loop and then this second L2 and then third L3 is also touching. So value of delta 2 will be also equal to 1 only. I hope that you have understood how we have calculated the value of delta 1 and delta 2. Any doubt? Yes, please. Now just you have to put those things in the formula. So what is C by R or overall transfer functions? That is equal to, in the numerator, P1 into delta 1 plus P2 into delta 2 plus there is no P3, so divided by delta. So we have calculated P1, we have calculated delta 1, we have calculated P2, delta 2 and delta. So just we have to put those values in the formula. So C by R equal to P1 into delta 1. So P1 is basically this G1, G2, G4. What is the value of delta 1? It is 1. So this multiplied by 1 will be equal to same thing. Then P2 is the G1, G3, G4 multiplied by delta 2 is 1. So it is same. And divided by this delta is already calculated to 1 minus Z1, Z4, H1 plus Z1, Z2, Z4, H2 plus Z1, Z3, Z4, H2. Now, by simplification of this one, you'll get G1, Z4 common here and G2 plus Z3 divided by this one. So this will be the overall transfer function of given problem, right? So you don't have to reduce any block diagram directly. By using Mason's formula, you can calculate the transfer function, right? So we'll stop here. Tomorrow we'll see some complicated problems on the signal flow graph. If you have any doubt, I'll be happy to answer your doubt. So over to you. Yes, please.